A campground charges $20 per night. They average 56 groups of campers each night. A survey indicated that for every $1 decrease in price, the number of camping sites rented would increase by 7. What price would maximize the nightly revenue? So I'm a fan of these questions. I think they're a lot of fun. But the challenging part is going from words describing a scenario into equations, right? Into the math itself. So for this, we really have to envision what's going on. So you have a campground, and they charge the people $20 to come and stay the night. And typically, they have about 56 people on average staying each night. So we could figure out right now how much money they make each night, right? $20 times 56, that would tell you how much revenue they're bringing in right now. Now, a survey that they conduct indicates that if they drop their prices by $1, so if instead of $20 per night, they only charge $19, that would make 7 more camping groups decide, yeah, we want to go camping there as well. And so instead of 56 groups, you'd have, 63 groups, right? 7 more groups would show up. And so the question is, how many decreases in their price, how many times do they have to drop their price by $1, would maximize the amount of revenue, right? So they want to make the most money possible. How would they achieve this? Okay, how many times do they have to drop their price? And we can come up with some equations for this, right? First off, we can state that the revenue is equal to the number of sites that you're renting out multiplied by the cost per night. Right, because currently it's 20 times 56, right? That's what it is right now, but that can go up as we're seeing from the survey. They're saying we can make that bigger. So what we can really say is that revenue is equal to, well, the number of sites right now is 56, but it can go up 7 every time we decrease the price. So I'm going to say X represents the number of times we decrease the price. So if you decrease the price once, 1 times 7 is 7, so 7 plus 56, you'd get to your 63. If you decrease the price twice, then 2 times 7 is 14, you get 14 more sites rented out instead. So just like that, and then cost per night, well, the cost is $20 minus $1 times the number of decreases, right? So if you decrease the price once, this goes to 19. If you decrease the price twice, this goes to 18, right? And so on and so forth. And so the question is, what value of X would we have when the revenue is maximized? Well, we have to realize this represents a quadratic equation, right? This is a quadratic function. And you can figure out where the maximum is, right? The vertex, if you were to graph this, by looking at the roots and then taking the average, right? So what are the roots here? Well, set each of these equations to 0. 56 plus 7x equals 0, and 20 minus x equals 0. This one's pretty straightforward, right? It's 20 equals x. This one over here, you move the 56 to the other side, divide both sides by 7, and you get x is equal to -8. So you get -8 and 20 as your roots. So if we were talking about graphing this thing, it would look something like this. You'd have 20, you'd have -8, and it would be going like this. Now it obviously continues, right, like down like this and down like this, but in reality, you're not going to have negative revenue, right? You're never going to get to that point. So we have to find this maximum point right here. We want to find that maximum value, right? The maximum revenue that we have. So that's your revenue. This is the amount of decreases. So we want to find this point right here. How do we find that? Well, it's exactly halfway between your roots. So all you have to do is -8 plus 20 divided by 2. That's 12 divided by 2, that's equal to 6. So 6 is where the vertex is. So 6 is your answer, right? 6 decreases of $1. So if you do 20 minus 6, that's equal to $14. So $14 is the price that they should charge in order to maximize their revenues. Now, if you want to know what those revenues would be, if you were charging $14, well, you just plug your 6 into your equation up here to calculate the revenue. If you do so, you would have 56 plus 7 times 6 times 20 minus 6. And if you do that, you'll get your revenue is equal to $13.72, and that's per night, right? That's what we're talking about here is the nightly revenue. So that, compared to your original situation, which is 56 times 20, right? You're having 56 sites rented out at $20 per site. Well, 56 times 20, that's equal to $11.20. So you've increased your profit by more than $200, right, by dropping your prices to $14 from $20. Hopefully that question makes sense. Okay, let's do another one. This is a fun question. You have 100 meters of fence to place against a wall. The final shape must be a rectangle. What are the dimensions and the maximum area? So in the past, when we talked about maximizing the area, given that we have some amount of fencing, we always said that you should make it a square because a square maximizes your area for a particular perimeter. That's not quite what we have here. And if you couldn't tell from the question, let me show you what I mean. You have already a wall, like maybe this is the back of a house or something. And then you have some fence, right? 100 meters of fence. And you can place that fence like this. And you're trying to maximize this area. So this fence, you don't have also a piece of fence here against the wall. That would just be a waste of fence. You only have fence on 3 sides. So the rules for maximizing this area are a little bit different, right? I'll label this W and W for width, and this is L for length. And we can come up with a couple equations, I think, to talk about this. For one, you could say your 100 meters of fence is equal to L plus 2W, right? Because, again, just these 3 sides are made of fence. And you could rearrange this, right? You could solve for L. You could say L is equal to 100 minus 2W. And you can also come up with an equation for your area, right? Area is going to equal width times length, right? Length times width. And you can substitute in, because L is equal to this, you can plug that in for L. So let's do that. Area equals width times 100 minus 2W. This is a quadratic, is it not? If you were to multiply this out, you would get 100W minus 2W squared, right? That's a quadratic function. So what are the roots of this function? Right, what are the roots? Well, you just set this to 0 and this to 0, and you solve for W, right? So either W equals 0 or 100 minus 2W equals 0. If you solve for W in this case, you're going to get 50 equals W. So those are your 2 roots, right? 0 and 50. So if you have a little sketch like this, at 0 and at 50, that's what your function is going to look like. And so to figure out, okay, where's the maximum? Well, it's halfway, right? It's at 25. 25 is halfway between 0 and 50. And so the maximum area occurs when you have 50 as your width, right? Because this function is a and w, so a and w instead of y and x. So this x-axis represents your width, so 25 meters would be the width that maximizes this. Now, we were asked for the dimensions and the area, so first let's figure out the length, right? Because we only have the width so far. We know that the length is equal to 100 minus 2w, or 2 times 25. 2 times 25 is 50, so 100 minus 50 is equal to 50. So your length is equal to 50 meters. So length equals 50 meters, width equals 25 meters, right? So that's the answer for your dimensions. Now you also were told to find the area. Well, area is length times width, right? So 50 meters times 25 meters. Therefore, your area is going to equal 1,250 meters square. So, just as a final answer, your maximized area is going to look something like this. You have your wall, you have your fence like this. This width over here is 25 meters. Over here as well, your width is 25 meters. You have a length here of 50 meters. Sure enough, those all add up to 100, right? 25 plus 50 plus 25 adds up to 100, and that gives you a maximum area of 1,250 meters square. And that's your final answer.